Welcome to review day 13. We're taking a look at some trig. Trigonometry, if you remember, is all about happening for our course in right triangles. So when we notice that we have a right triangle, all right, and we're looking for some missing parts, either we're going to be talking about just side lengths, right? Or we're going to be talking about using sides and angles. So there's two formulas you need to remember when we start talking about right triangles. One is the Pythagorean theorem, and this is only when we have side lengths. So as soon as we involve an angle, okay, then we have to switch over to SOHCAHTOA. All right, when there's an angle involved. Okay, so let's take a look at a few questions. So the big thing we're going to talk about, remember, is when we write out SOHCAHTOA, we're going to be writing out SO as in sine is opposite over hypotenuse, CA adjacent over hypotenuse, and tangent opposite over adjacent. So when we're looking for which of the functions to use, sine, cosine, or tangent, we want to remember that step one is going to be to find your angle. Are we using angle A or B here? Which acute angle is it? That's our reference angle. We want to label our sides opposite, adjacent, and hypotenuse. And then based off of that, we are going to pick our trig function and then plug in. Now, the first few questions here don't involve actually doing a lot of the work. So all we need to do is now, what we're going to talk about in the first few questions is the fact that anytime you have a right triangle, we have two angles that are going to be complementary, which means that they're going to equal 90 degrees, okay? Okay, so when we're looking at the two triangles, notice that the two complementary angles are always going to be the angles that are, okay, not the right angle. So when the right angle is angle C, okay, angles A and B have to add to 90 degrees. These are the complementary angles. So the two angles that are not the right angle I refer to as the complementary angles. So that means if we know angle A plus angle B is equal to 90, okay, if we know that that's true, then what we know is that the sine of A is equal to the cosine of B, and the cosine of A is equal to the sine of B. Because remember, as we change from angle A to angle B, so just moving off to the side here real quick, in a right triangle, okay, when we find our reference angle, or if our reference angle is at A, okay, the sine of A is equal to the opposite leg over the hypotenuse. So it's a ratio of BC over AB. And when I change from angle A to angle B, in order to use the same ratio of BC over AB, I have to use the adjacent leg to make it BC and the hypotenuse to make it AB, which adjacent over hypotenuse is the cosine. So when we change from one complementary angle to the other, okay, the ratios stay the same as long as we switch, because we flip-flop the adjacent and the opposite, as long as we change from sine to cosine. So that's what we're referring to in these first questions, okay? So if you look at 369, which in scaling triangle ABC shown in the diagram below, which is always true. So if we're using A and B, we never use the right angle for SOHCAHTOA, because when we talk about opposite and adjacent for opposite or hypotenuse for sine, it's always the same side, and there's no adjacent leg to angle C. We're not really sure what it is. So we would want to look to make sure it says sine of A and then cosine. That one doesn't say. Cosine of A and then sine. That one doesn't say. Cosine of A and then sine, but this is angle C. We don't want to use that. So here is one we want to pick where it's sine of A and then cosine of B. Okay, so we don't want this to be sine. we wouldn't want this to be cosine, and we wouldn't want this to be the right angle. So we want to choose number 4. 375, that's right next door. Remember that in a right triangle, okay, the acute angles, so if we know that the sine of A is equal to the cosine of B, here's A and here's B, then we would know, okay, that angle A plus angle B has to equal 90 degrees because it's a right triangle. So we would just set 2x plus 4 plus 46 is equal to 90, and then we could solve. Okay, so plug in and then combine like terms. We get 2x plus 50 is equal to 90. We move that 50 over to make 2x equal to 40. And then we would divide by 2, so we get x is equal to 20. And there's our answer for the number 375. Okay, coming back up to 367 and 368. Both of these involve similar triangles. So when the triangles are similar, now in this question, we want to know which one of these is true, essentially, okay? So that's what's being covered up here. We would know that since the triangles are similar, that angle J here, okay, is going to be equal to angle E, all right? And then angle T is going to be congruent to angle R, because those are the corresponding angles. So if we were to figure out, okay, what the cosine of J is, in this small triangle, we remember that with SOHCAHTOA, that cosine is adjacent over hypotenuse. So from J, okay, from J, the adjacent side would be JM over the hypotenuse, which is JT. And when we look, cosine of J, we don't see JM over JT. We do see it here, but this says R. And this should be J in order for this to be true. So we're not going to pick this choice. And we don't see any other ones that reflect that. Now, keep in mind, we also, instead of using J, because we know J and E are equal, we could create the ratio using angle E instead. Okay? So if we use the cosine of angle E instead of J, which these are going to be equivalent, then we would do adjacent over hypotenuse again. Okay, and we would do ME over RE or ER. And these are would be equal because these angles are equal, so the ratios are going to be the same. And when we check, here's RM over EM, and none of these work, right? And more so, we know that cosine of J should not equal RM over RE, right? So this should be ME or EM, so we know that number 1 is also not a choice. That means we'd have to be using either angle T or R, and since we're doing tangent for both, what if we did the tangent of R? Now the tangent of R, remember, is equal to the opposite over the adjacent. So the opposite leg from R is ME over the adjacent leg from R, which is MR. Okay? Which is not working out, but remember that R is the same as T, so that means that also equal to this is going to be the tangent of T, and that would be the opposite leg, which is JM, over the adjacent leg from angle T, which is TM. And we don't see JM over TM, we see this flipped. And now remember, tangent of T is not RM over EM, so this is out, and we know that number 4 has to be our choice. And we can actually find, right, the tangent of E by actually labeling the opposite, which would be RM, over the adjacent, which is ME. So the tangent of E is equal to the tangent of J, and the tangent of E is RM over ME, and the tangent of J is equal to opposite over adjacent, TM over JM. And since these two things are equal, this ratio is also equivalent to this, we would want to pick choice 4. So in the triangles, what we're essentially saying is if the triangles are similar, you can make the ratio using the angle in the small triangle or the angle in the big triangle, and those ratios are going to be the same. So if it says E, not only do you want to check the tangent V, you want to check the tangent of the other congruent angle, which would be J. And either of the ratios could be an answer. 368 is the same type of question. Here we know that the lines are parallel to one another, okay? And so if they're parallel, all right, that tells me that these angles have to be equal and they share angle A. So that means that we have two triangles once again, and these two triangles are going to be similar, okay? So if it says which ratio is always equal to the sine of A, all right, we are going to check the sine of A in both triangles. So in the small triangle, all right, the sine of A is equal to the opposite over the hypotenuse. So it's going to be BC over AB. And notice that that is a choice, which would be option 3. Or in the really big triangle, right, we have AED, the sine of A using opposite over hypotenuse, could have also equaled DE over AD. Okay, and that would be kind of flipped here. So this one's out, that one's out, and then it's got to be choice number 3. All right, going down to 372. These two questions down here are giving you one of the ratios. So they're telling you what the ratio of the cosine of A or cosine of B is, and it's asking you to figure out another ratio. So what we're going to do, it's pretty easy, is we're going to draw ourselves a right triangle, okay? We're going to label where angle B is, and then we're going to label the ratio. Now we know that angle C is the 90-degree angle. So if we do the cosine of B, the opposite side is across, the adjacent is next to, and the hypotenuse is listed. The cosine of B is 5 over 13, so 5 would be the length of BC. I'm just going to change colors real quick. Okay, and 13 is the length of AB, which function is also equal to 5 over 13. Well, remember, we have to use angle A instead of angle B. Okay, and so for angle A, it would be the opposite, and the adjacent would flip-flop, so it would be opposite over hypotenuse. So that would be the sine of A would equal 5 over 13, and that would be my answer. Okay, question 377. Angle C is a right angle. So once again, we have to draw on this out for ourselves. All right, we have A and B. The cosine of A, so once again, cosine is adjacent over the hypotenuse, would be square root of 21 over 5. And we want to know what is the sine of B. Remember that the cosine of A is equal to the sine of B. So if we figure out where B is, right, the sine of B is opposite over hypotenuse. And so we are going to get the square root of 21 over 5 again. And that is our answer. All right, the next questions are just finding the lengths of missing sides or ratios. So for all of these questions, remember the step 1, okay, for 383, is going to be find your angle. Find the reference angle. 2 is going to be the label the sides. All right. 3 is going to be to set a proportion. And 4 is going to be to solve. Now the solving part is either going to be cross multiply or the inverse, depending on if you're looking for the angle or the side. So let's look at 383. We have the diagram shown below. Now the angle of elevation is always made, okay, when you are down on the bottom and you are looking up at something that's high above, like a tree or a cloud in the sky. Okay, the angle of depression would be if you are up on top of the mountain here and you are looking down to the person below. Remember though, the angle of elevation and depression are congruent, so we always want to put it in the bottom corner of our triangle. All right, so if the point is 20 feet from the base of the tree, we just want to figure, and this question should say the diagram is kind of covering up, what is the height of the tree to the nearest foot? So we'll call that x. So once again, find the reference angle, 34 degrees. Label the sides. X is opposite, 20 is adjacent. Pick your trig function. So our trig function using opposite and adjacent, if you remember our SOHCAHTOA is going to be tangent. So the tangent of 34 is equal to, the tangent of the angle is always equal to the ratio of the sides. The ratio of the sides is opposite x over adjacent 20, and then we're just going to cross multiply. So 20 tangent of 34 is equal to x. And then I'm just going to use my calculator and multiply this out. So the trig button, remember, is right next to the number 7 here. We're going to do tangent of 20. We're always going to go outside the parentheses or in front. So you can either do either one. And then we're going to do times 34. And we're going to round to the nearest whatever it says. And it says nearest tenth. And so we're going to get 12 point, well, time out. Oh, we did that backwards. We did tangent of 20 times 34. So let's try that again. We want to do 20 times the tangent of 34. And we're going to get 13.5. And that is going to be our answer. Okay? Question 384. If the tangent of theta is equal to 3 over 7, what is the value of x to the nearest tenth? So this is a little bit different here. When we look at theta, which is here, once again, we're going to find a reference angle. We're going to label the sides. So the tangent, if you remember, is opposite over adjacent. So the opposite from theta is this side, 3, and the adjacent is 7. All right? Now, these two triangles, notice, are similar triangles because we have two sets of congruent angles. So theta would be the measure of this third angle over here. So that means, right, that the tangent of theta is not only equal to 7 over 3. In this triangle, the tangent of theta is also equal to the opposite over the adjacent, which would be 2.4 over x. And since these are both equal to the tangent of theta, we can make a proportion, 7 over 3 equals 2.4 over x, and we can cross multiply and solve. So we're going to get 7x is equal to 2.4 times 3 is 7.2. And since that is equal to 7, we just divide by 7, get x by itself, and we get 1.03 here. So quick fix here, the tangent is not 7 over 3, it's 3 over 7. So it's opposite over hypotenuse. So from here, it should be opposite over adjacent. Apologies. It should be 3 over 7 is equals 2.4 over x. So if you notice when we plugged it in the calculator, we got what should be 1.3, which wasn't an answer. So that's how we know we got to go back and double check this. So if we flip it to 3 over 7 equals, okay, we're going to get 3x and then 7 times 2.4. And then divided by 3 is going to get 5.6. That should be our answer. So hopefully you notice we were doing that wrong. All right. We'll be good to go from there. We're still on a highlighter. And this was 16.8 divided by 3. And there's our 5.6. Okay, finish up these two, and then we're going to take, I'll send a part 2 video in a second. Going to help a couple students with that stuff. So for 385, given the value of the right triangle, what is x to the nearest foot? So once again, we're going to find our angle. We're going to label our sides. So this is adjacent and hypotenuse. And then from our SOHCAHTOA, we're going to pick out what function we are using. Since we have a and h here, we're going to use cosine. So the cosine of the angle, 40, is equal to the adjacent leg, which is 14, over the hypotenuse x. Now, unlike last time when we cross multiply, we are not going to be done right away because we have x times the cosine of 40 is equal to 14, and then we're going to have to divide out by the cosine of 40 to get the answer here. So remember, we're looking for a side. We're always going to cross multiply. So 14 divided by, I'm going to press the trig button, choose cosine, and then 40, and we get 18.27. It does say nearest foot, so that's going to be 18 feet. And that's choice 3. Okay, in 394 off to the right. So what happens is we have a ship heading directly toward our lighthouse, and the beacon is 125 feet above sea level. So the height of this triangle that we have here is 125 feet. Now, the angle formed, okay, for the angle of elevation, remember from the bottom corner, is going to be 7 degrees. So what's going on in this figure is we have 2 triangles being made, okay? We have triangle ABC, which has an angle of elevation of 7 degrees and a height of 125. And we also have a ship that moved up to point D now, and the angle of elevation to point D is 16 degrees, and the height is still 125. So D, B, C. So once again, what we need to figure out is how far did the ship travel to get from A to D. And to do that, all we're going to do is figure out the length of this bottom side, whatever this is down here. We're going to figure out the length of this part right here, and then we're just going to subtract them to get the length of our highlighted region here. So we're going to do AC minus DC. And because we have right triangles, we have our angle measure, we're trying to find this side out first. We'll call it X. We have opposite and adjacent from 7. So we can do the tangent of the angle is equal to 125 over X. And in the smaller triangle over here, we're looking for this side, we'll call it Y. We also, once again, have the opposite and the adjacent. So we're going to do the tangent of 16 is equal to 125 over Y. In both instances, we're going to cross multiply because we're looking for a side. We're not going to have an answer right away because we're going to have X times the tangent of 7 is equal to 125. So we're going to have to divide out by the tangent of 7 to get the answer. And so we should get X is equal to, so 125 divided by the trig tangent of 7 gives us 118 and change. We'll go 0.043, 1,000 I should say, 18.043. And you can keep writing this out, but 3 decimal places should be appropriate. And then we're going to do the same thing here. So we cross multiply, we're going to get Y times the tangent of 16 is equal to 125. And we're going to have to divide by that tangent of the angle to get our final answer. So 125 divided by the trig tangent of 16 is 435.927. And so the length of AD is going to equal the difference between these two things. So 1018.043 minus 435.927. Now, on our calculator, we're going to actually use the numbers we got. So up arrow, select, okay, minus the 435.927. Notice we have even more numbers here. So this answer will be more exact. And we get 582 feet. Let's say the nearest foot. So we know AD is equal to 582 feet. Okay, that'll be it for part 1. Part 2 coming at you, finishing up the rest of our SOHCAHTOA.